rational expression by a polynomial. And really, this is just the same as multiplying a rational times a rational. It's just that this second piece here doesn't have a denominator. So really, you can just put it over 1, and then you treat it like multiplying a fraction times a fraction. So what we're going to do here is we're going to take the first part, x plus 2, over this. We're going to go ahead and factor. So when we're multiplying these expressions out, we always want to sort of factor it out so we can see if anything's going to cancel once we get everything put back together again. Like I said, this guy over here, x cubed plus 4x squared minus 12x, we can put that over 1, and then we can go ahead and start the factoring process. We're going to bring out the x, and then we still have two pieces right here and here that can be factored a little bit more. So let's keep going with this. And we'll leave the top x plus 2. On the bottom, we have x squared plus 4. This guy right here, x squared minus 4, that's the difference of squares. That's going to be x plus 2 times x minus 2. Now, again, when we're multiplying, basically, all we do is put everything in one big fraction. And this is going to join the numerator. So times x times, let's go ahead and factor this now. We need two factors of negative 12, I think 6 and 2, x plus 6, x minus 2. Yeah, that should work to give us negative 12 and positive 4x. So now with multiplying fractions, everything's in one big fraction. And at this moment, we're going to go ahead and establish the domain by stating what x cannot be before we start to cancel anything out. So here are the two danger zones right there. Negative 2 would produce 0, and positive 2 would produce 0. And now we can go ahead and look for common factors to cancel. So x plus 2, x plus 2, cancel. X minus 2, x minus 2, cancel. And we are left with x times x plus 6 over x squared plus 4. Nothing else cancels, and there are no other restrictions to the domain. In case you were wondering about this factor right here, there's no value for x, no real number anyway for x, that would make this factor equal 0, so it does not affect the domain. Okay, so we are actually done with this one, and this is the product of these two expressions. So go ahead and do the two triads on your own. At this point, and let me know if you have any questions.